Let's use Fathom to take a look at some data that we've already taken a look at in class. Here we have 30 students, and we have the rows that they are seated in along with their test score, and we're wondering if these data provide convincing evidence that sitting closer causes students to get higher grades. The students are randomly assigned to sit in a particular row. So I'm going to put row on the x-axis and score on the y-axis as I create my scatter plot. And it appears that there's a mild negative linear association. Let's get our least squares regression line. Our coefficient of determination here is 0.046, and the slope is negative. This slope of about a -1 would indicate that your score would go down by 1 point for each row you sit further towards the back of the room. But the question is, would we be likely to get these results by chance alone? In other words, these students and their scores, if there's no relationship, they would have gotten these scores no matter where they sat. So let's redo this data set and scramble the scores. So I'm going to scramble attribute values, and I want to scramble the score. And just to convince you that the scores have been scrambled, notice there's still 30 cases here, just like we had over here with 30 students. In the first row, the very first observation has a score of 88, which is not what we have here. And then we have a score of 90, which is not what we have here. So it appears that the scores have been scrambled, but not the rows. Well, let's actually calculate some more values for the slope. I'm actually going to do a model here. I'm going to do a simple linear regression model, and my response attribute is going to be score, because score is responding based on the row. So let's take a look and see what we have here. We can see that this least squares regression line for this set of scrambled data also is negative 1.41 approximately. And we have an R-squared value of 0.077 instead of 0.04 that we had earlier. Let's actually collect some measures, and what I mean by that is we're going to scramble and calculate the least squares regression line, scramble and calculate the least squares regression line, and we're going to gather the slope and the y-intercept and the correlation coefficient. Remove the verbose there, and notice there's also a confidence interval given for the slope. Let's collect results as measures, and let's just see what's in there. We've got our correlation, our intercept, our slope, and so on, but we want to do this a total of not 95 times. I need to do it 95 more times, so I have a total of 100. So I have 100 cases in here, and let's take a look at a graph of the slope, or a dot plot I should say, of the slopes. Now if there really was a relationship here that sitting closer causes students to get higher grades, we'd expect that the slopes should all be negative, or most of them should be negative, indicating that the further you sit back in a class, the lower your grade. Let's look at the slopes. So some of them are negative, which is good, but notice there's quite a few of them, nearly half of them I would say, or at least 40% of them, where the slope was positive. So I would say that these data definitely do not provide convincing evidence that sitting closer causes students to get higher grades.